Hi, so for today we are going to continue our 1001 Solve Integrals Part 2. So this will be number 11 and let's try to solve again 10 problems in the integrals. Okay, so for this topic we have, for number 11, we have the integral of sine cube of y cosine y dy. So how do we integrate this? First of all, we need not to have any trigonometric identities here because this is simple u substitution. So if we let u equals to sine y, and we have to get the derivative of sine y with respect to y, that's cosine of y dy, of which our cosine of y dy is readily available in our integrand. So that if we are going to perform u substitution, since this is a sine y of cubes or sine cube of y, or it can be rewrite as this sine y cubed, and then we have cosine of y dy. So easily, because of our u substitution, we can substitute u here. So we have u cubed, and then we have cosine y dy would be our du. Okay, so that would be our du. So this is only for power formula, u raised to 3 plus 1 all over 3 plus 1. Then we have plus c. So this would be u raised to 4 all over 4 plus c. But we need to substitute back whatever is the original variable, which is y. So, but u equals sine y. So we have sine of y raised to 4 all over 4 plus c. So that is how you solve this integral. Okay? So let's go now to number 12. Okay, so number 12, we still have cosine, integral of cosine of x, and then we have dx all over sine raised to 4x. Okay, so this is still a simple u substitution. So we will just manipulate first the integral by reciprocal, okay, getting the reciprocal of sine raised to 4. So if we reciprocal that, so we'll be getting sine raised to negative 4. We negate the exponent, and that would be multiplied by cosine x dx. So that is as simple as u substitution as our first example, because as we all know that if we let u equals sine of x, then we have du as cosine of x dx. The derivative of sine is cosine. So we can now freely substitute. So as I have said, sine of x raised to sine of negative 4 of x would be can be rewritten as this, okay? So that we can have the u substitution. We have u raised to 4, negative 4, then we have du. So this is only power rule. So we have u raised to negative 4 plus 1, negative all over negative 4 plus 1, and then plus c. So we have u raised to negative 3 all over negative 3 plus c. But take note that our u is sine of x. So we have sine of x raised to negative 3 all over negative 3 plus c. Okay? So it's a common thing that we rewrite the final answer as one having a positive exponent rather than a negative. So we can get the reciprocal. Simply, this would become negative 1 because of the negative here. So I just rewrite it as in the numerator. And then we have negative 1 all over 3 sine of cube x, okay, plus c. So this can be our final answer, or this can also be our final answer, negative 1, 3 sine of x cubed plus c. So that can be also our final answer for this. For this number 12 problems, okay? So we still have more to go, okay? This is a 1001 solved problems in integrals. So let's get to the other example, to the next example. For number 13, we have the integral of sine 4x. Then we have cosine of 4x dx. So again, we can let, okay, u, since this is sine and cosine, we can let u as sine 4x, okay? So get the derivative of sine 4x. So first, get the derivative of sine 4x, that's cosine 4x. And then differentiate the inside function of the sine, which is 4x with respect to x, that becomes 4. And we multiply it with the cosine 4x that we got. Okay? So that the derivative would be 4 cosine 4x. So, how do we do that? We have cosine of 4x dx here in the integrand. So, we can isolate cosine 4x dx by dividing both sides by 4 as this. Okay? So that we have du all over 4 equals 4 cosine or cosine 4x. So that without any problem, we can now substitute. We have sine of 4x that is actually u. Okay? Sine 4x is actually u. And our cosine 4x dx here equals du all over 4. So we have du all over 4. So now we can factor out 1/4 outside of the integral sign and we have u du. So we integrate that. So we have u raised to 1 plus 1 all over 1 plus 1. Okay, and then we have plus c. So that we have 1 all over 4. And then we have u squared all over 2 plus c. But take note that our u is sine 4x. So we need to substitute it back. So we have 1/4. And then we have sine squared of 4x all over 2 plus c. So, simplifying that, we have sine squared 4x all over 8 plus c. Okay? So, all over 8 plus c. Or you can also rewrite the answer as 1 uh, having the 1 all over 8 separated. Okay? So, any of that will do. So, that's right. That will be our final answer for number 13. Let's go now to number 14. For number 14, we're going to solve the integral of the 4 minus, I think it's 4 minus 3 sine 2 beta. 3 sine 2 beta. Then we have cosine 2 beta and d beta. Okay? So, again, this is still u substitution. If we are going to observe inside of the integral, we have sine 2 beta and we have cosine 2 beta here. So if we are going to let u, okay, 4 minus 3 sine 2 beta, okay, we get the derivative of that as 0 minus 3 cosine of 2 beta and then differentiate beta to beta. So that would be 2 d beta. So we have du and then we have negative 6 cosine 2 beta d beta. And as we can see here, we have cosine 2 beta d beta. So we can extract it from the right side of the equation of our u substitution, du, so that we can isolate negative that term cosine 2 beta d beta by dividing negative 6 both sides. So now we have that. We can now perform u substitution. So our u would be the entire 4 minus 3 sine 2 beta. And then we have cosine 2 beta d beta as du all over negative 6. Okay? So that would be du all over negative 6. That is du all over negative 6. So we can factor out negative 1 all over 6. And then we have u du. So we have negative 1 all over 6 integral of u du. That's power formula. So that becomes a u1 plus 1 all over 1 plus 1. U raised to 1 plus 1 over 1 plus 1. So we have negative 1 all over 6. U squared all over 2. Then plus c. And now, it's time to substitute it back to the original variable, which is the beta. Okay, our u is equal or equals what? It equals 4 minus 3 sine beta or sine 2 beta, I mean. Okay, and then squared. So because of the squared, all over 2 plus c. So we have an answer of, we have negative, okay, 4 minus 3 sine 2 beta squared all over, we have 12 plus c. So that can be our final answer. Okay, or we can factor out or we can Or we can factor out negative 1 all over 12 so that we have negative 1 all over 12 and then we have 4 minus 3 sine 4 minus 3. So we have 4 minus 3 sine 2 beta squared plus c. So we can have that as our final answer. Okay? So that would be our number 14. For number 15, we have number 15 as the integral of sine t dt, sine of t dt, all over 4 plus cosine t raised to 3 halves. So 4 plus cosine t raised to 3 halves. Okay? So this is still in terms of sine and in cosine. So what I would like to do here is I could raise 4 plus cosine t raised to negative 3 halves, and that is multiplied by sine t dt. So if I'm going to let u, again, let u equals 4 plus cosine t, okay, without the exponent. So we have du as 0. Derivative of cosine is negative sine. So we have negative sine t, then we have dt. So we have du equals negative sine t dt. Why do we do that? Because we have sine t dt here. Since I only have sine t dt, I will be multiplying this both sides by negative 1 so that this becomes negative du. Then we have sine t dt. And now we can perform u substitution in here. So we have the integral, 4 plus cosine t, we made it as u, and then it's raised to negative 3 halves because of the exponent, okay, the negated exponent, because we've gotten the reciprocal of that, so that's why it became negative 3 halves. So, and then multiplied by sine t dt equals negative du. So we have negative du here. So that becomes u raised to negative 3 halves plus 1 all over negative 3 halves plus 1. And of course, we can factor out the negative here. Okay? So we have the negative 1 here to factor it out. So we have forgotten that. So that we will be having another negative here before we do the integration. Okay? So this would be equals the negative. So that's the negative that we have gotten here. So that tiny little negative here. Okay? And then we have plus c. So we have negative 3 halves plus 1 would be actually negative 1 half. Okay? So because negative 3 plus 2 is negative uh, 1 all over 2. So we have u raised to negative 1 half all over negative 1 half. Of course, don't forget the negative here, plus c. So we do have what? Get the reciprocal of negative 1 half and multiply it by negative. So that becomes 2. Okay? Negative 1 half. We get the reciprocal, right? So we have u raised to negative 1 half plus c. Okay, okay. So what are we going to do here? Next is just to simplify our answer. So we have u. What is u? It is equal to 4 plus cosine of t raised to negative 1 half plus c. So you can write it as it is, okay, but it's good that we have a positive exponent. It's a good practice that we have a positive exponent on our on our final answer so that we can negate it again by getting the reciprocal. So we have 2 all over 4 plus cosine t raised to 1 half plus c. So that could be our final answer also. Or 2 all over square root of 4 plus cosine t 1 half. So that could be our final answer. Okay? So for number 16, we have to find the integral of cotangent alpha, then cosecant squared alpha d alpha. Okay? So now we can use substitution. Okay? You use substitution in here. So we can let u as what? As the cotangent, because cotangent of alpha, what is the derivative of cotangent? O cotangent of x or cotangent of alpha, that would be negative cosecant squared of alpha d alpha. So it's very easy, right? So we have cosecant squared alpha d alpha here. So I'm going to multiply negative both sides of the equation of this du. So we have negative du. Then we have cosecant squared alpha d alpha. So that we can now perform u substitution. So that we have cotangent alpha would be u. And cosecant squared alpha d alpha would be negative du. Okay? So we have negative du in here. So we have negative integral of u du. So that's negative u squared all over 2 plus c. So that we have negative, what is our u? That's cotangent squared alpha all over 2 and then plus c. So in other words, we have negative 1 half cotangent squared alpha plus c. So that would be our final answer for getting this integral. Okay? So, number 14. Okay, let us try number 14. Ah, number 14. I mean, number 17. Okay, what I'm trying to say is number 17. I'm so sorry. So, we have cotangent of z and then cosecant of cotangent, integral of the cotangent of z. Then we have cosecant cube of z dz. Okay? So again, we're going to let you, okay, some of the variables here, we're going to let you. So we can factor out first one factor of cosecant. Okay, so we have cotangent of z, so we have cosecant squared z, and then we have cosecant z dz. So we have split off one cosecant here. So the purpose, it's because, okay, if we are going to let u as the cosecant z, we know that the derivative of that should be negative cosecant z cotangent z. Okay? So that's the derivative. So we already have negative cosecant z cotangent z in our integrand. So that is where, okay, if we are going to rearrange this such that we have cosecant squared z and then we have cosecant z cotangent z dz. So we have this term cosecant z cotangent z dz in our integrand, and that is present in our du, which is we have cosecant z cotangent z except for the negative. So we're going to multiply this both sides by the negative one. So we have negative du. Then we have cosecant z cotangent z dz. So now it's very easy for us to integrate because we can now substitute the u substitution. So we have cosecant squared z equals u. Okay, cosecant z is u. So we have u as cosecant. Since this is squared, so we have u squared. And then that would become negative du. Cosecant z cotangent z dz equals negative du. So we have negative integral of u squared du. So that would be simply negative of, by power rule, we have u cube all over 3 and then plus c. So we have negative, what is u cube? Our u would be cosecant cube z all over 3 k plus c, or in other words, we have negative 1/3 cosecant cube of z plus c. So that would be our solved integral for this problem. Negative 1/3 cosecant cube of z, okay, and then 1/3 cosecant cube of z plus c. So for number 18, we have the problem of the integral of d beta all over beta ln raised to 4 of beta. So this might seem a problem that is so difficult But if we are going to rearrange this such that we rewrite this as 1 all over ln of 4 beta, okay? And then we have d beta all over beta. So we know that we can furthermore rewrite this as 1 all over ln of beta raised to 4. Then we have d beta all over beta. Okay? So what are we going to do here instead is we are going to what? Reciprocate the ln beta but by negating its exponent. So in that way, we can see what are we going to do with that integral. As you can see, this is ln of beta. And if we get the derivative of ln of beta, that is d beta all over beta, as well as we get the ln of x, the derivative of ln of x, okay, that is dx all over x, or 1 all over x. So since we differentiate with respect to x, we have dx all over x. So if we are going to let u here as ln of beta, and then we're going to get the derivative of u, okay, with respect to beta, that would be 1 or over beta, okay, and then since we have the beta, we differentiate with respect to beta, so that we have the du as a d beta all over beta. Okay, so if we do that, we can now proceed with our u substitution, so that we have integral of ln beta is u, okay, in our u substitution, and that is raised to negative 4. And then we have du as d beta all over beta, so in which we have already in the integral, so that is du. So it's a power rule, so we have u raised to negative 4 plus 1 all over negative 4 plus 1 plus c. And then we have u raised to negative 3 all over negative 3 plus c. So we can factor out negative 1/3. Okay? Then we have u raised to negative 3 plus c. But it's a practice that we can write, okay, positive exponent, so that we will be getting the reciprocal of u raised to negative 3. And that would be 1 all over negative 1 all over 3 u raised to 3 only, because we already get the reciprocal by negating its exponent. So, but our u equals ln of beta. So, our answer would be negative 1/3, okay, ln of beta cube plus c. Okay? So, or, in other words, we can rewrite it also as negative 1 all over 3, okay, ln of cube of beta plus c. So, we can also rewrite our answer as that, okay, for our integrals. Okay, so let's go now with number 19. So we have number 19 as our integral. So for number 19, we have the integral of x squared times the ln cube of 1 plus x cubed all over, then we have 1 plus x cubed, okay, dx. So this may seem a little hard to recognize as it is a simple u substitution. Why? Because of the complicated integral inside the integral sign. So we have x squared ln of cube, and then we have 1 plus x cube, okay, all over 1 plus x cube. So but as you can see here, guys, okay, so if I'm going to rewrite this as this, we have x squared, then we have ln of 1 plus x cube raised to 3 all over 1 plus x cube. It's getting more really easy to recognize. So if we try, actually, if we are going to try to get or to let u, okay, it's not integration by partial fraction. It's not integration by trigonometric substitution. It's not integration by a simple algebraic substitution. So, if whenever we see an ln here, okay, we always think that we can use it as a u substitution. So, let's try ln of the 1 plus x cubed. So, if we're going to get the derivative of ln 1 plus x cubed, first we differentiate 1 plus x cubed, that's 0 plus 3x squared. And that is all over the original value. That's how we get the derivative of an ln. Okay? So we have all over 1 plus x cubed. So that this is 3x squared all over 1 plus x cubed. So our du now would be 3x squared all over 1 plus x cubed dx. Okay? Present in the integral is what? Is x squared all over 1 plus x cubed, and then we have the dx. Okay? So if I'm going to rewrite the integral, we have what? We have x squared. Okay? I'm going to rewrite first the ln. So you have ln of 1 plus x cubed, okay, raised to 3, multiplied by x squared dx all over 1 plus x cubed. So this whole thing, if I'm going to rewrite also the du, so we have 3x squared dx all over 1 plus x cubed. So as you can see, it's the same. Okay? So we have x squared dx all over 1 plus x cubed. That is the same as this. Okay? So what I'm going to do is I'm going to isolate 3. So I'm going to divide both sides by 3 so that this would become du all over 3 equals x squared dx all over 1 plus x cubed. So that would be 1 plus x cubed. And now I can perform u substitution. Okay? U substitution because simply I can substitute, okay, the values of u and du in the integrand. So we have now integral of the u because we have chosen ln plus 1 plus x cubed as our u. So we have u. Take note, it is raised to 3. So that is raised to 3. U raised to 3. And then we have x squared dx all over 1 plus x cubed here, which is technically equal to du all over 3. So we have du all over 3 in here. So we can factor out 1/3 outside of the integral sign by properties of integral. So we can now evaluate 1/3, and then we have u raised to, okay, I'm going to evaluate here at the bottom. So we have 1/3. Then we have u raised to 3 plus 1 all over 3 plus 1, and then we have plus c. So that becomes 1/3 u raised to 4 all over 4 plus c. Okay, and if we are going to simplify, we have 1 all over 12 u raised to 4 plus c. But u equals what? U equals ln of 1 plus x cubed. So we can now substitute the value of u in our final answer because that's the original variable. So that we have 1 all over 12, and then we have what? Ln of 1 plus x cubed raised to 4 plus c. So that would be our final answer. Or you may find it that the other final answer would be 1 all over 12, and then we have ln raised to 4 of the 1 plus x cubed. So that is also another final answer. Okay. So that would be for our ninth problem, number 19. Okay? So it may seem difficult, but it's actually not difficult. Okay? So you just have to rearrange the integrals such that it would be easier for you to see what method you're going to use. In other words, we don't use anything aside from the u substitution yet. Okay? So for last number, we have number 20. We have to get the integral of e raised to t dt all over. We have the square root of 1 plus 5 e raised to t. 1 plus 5 e raised to t. So this is none other than, again, the u substitution. So if we're going to rewrite our integral as this, e raised to t dt, so we have the square root 1 plus 5e raised to t raised to 1/2. So I can reciprocal that, get the reciprocal by negating its exponent, okay, and then raised to negative 1/2, and then I have e raised to t dt in here. So if I'm going to let u, whatever is inside the this one, raised to negative 1/2, okay, excluding the raised to negative 1/2, so we have 1 plus 5, oops, I'm gonna use block, 1 plus 5 e raised to t. So get the derivative of u with respect to t, that is 0 plus, okay, what is the derivative of e raised to t? So we have 5, e raised to t dt is simply still e raised to t dt. So we have du 5 e raised to t dt. And if we are going to notice, we have e raised to t dt here. So that's why we chose that as our u. It yield to a du of having an e raised to t dt. So I have du. So I will isolate e raised to t dt on the right side of the equation by dividing both sides by 5. Okay, so that I have e raised to t dt here. So now you have this and you have the u. So you can now freely uh, use substitution. So 1 plus 5 e raised to t is our u. Since it's raised to negative 1 half, you have to use that. And then since e raised to t dt equals du all over 5, so we have to write du all over 5 in here. So we can factor out 1/5 outside of the integral sign, and then we have negative u raised to negative 1 half, and then du. This is by far by power rule. So far by power rule. Okay, we have 1/5. Then we have u raised to negative 1 half plus 1, negative 1 half plus 1 plus c. So negative 1 half plus 1 would be 1 half. So that would be u raised to 1 half all over 1 half plus c. So get the reciprocal of this and multiply it. Proceed to multiplication. We have 1/5 multiplied by 2, 2 all over 1, which is 2 also. And then we have u raised to 1 half plus c. So we have 2 all over 5. Okay, our u is, we have to back substitute the u. Okay, here, what's the value of our u? 1 plus 5e raised to t raised to 1 half plus c. So that would be our final answer for this problem. 2/5 multiplied by 1 plus 5e raised to t raised to 1 half plus c. And that's it. That is our part 2 of our 1001 solved integrals. So I think we'll be doing a 100-part video of this. So just for us to solve the 1001 integrals. So far we have solved 20 integrals. And then we have still 1001 minus 20. It's 981 integrals to solve. So please tune in. So, because I'll be uploading still or recording some of the integrals that we're going to solve in here. Okay? So again, thank you so much for listening. Again, if you are new to my channel, please don't forget to subscribe, like, and share this video with your friends. And of course, what are we going to do is, please, if you haven't watched the part 1, okay, you start a marathon with the integrals by watching part 1. Okay? So thank you so much again, guys, and God bless us all.